All right, we're back. We're on page 189 of math analysis, but 188 and 189 are really like one giant long problem with a ton of parts. So I already have a lot of stuff set up. Like I've already stored equations. I've stored these, all of these. We solve some stuff, which means that I have like some systems of equations and some solve things already in the calculator, which I may or may not be using. And then we stored this. And last time we answered location where the paths of the birds, bird 3 and 4 intersect, and the times at which they get there. And so we also, at the same time we're using the calculator, have been building this GeoGebra sketch that has everything kind of happening. It's got kind of a lot going on at this point, but that's good. Like the more stuff you can keep track of by correctly labeling and whatever, the better. It's like good habits to get into. So let's see if we can do the next one. Find how close birds 3 and 4 get to each other. So I mentioned last time that like, yeah, they get to the same point at some time, but not the same times, right? So t equals 6, bird 3 goes through that intersection point, and then what is that? 8.4. So 2.4 seconds later, bird 4 goes through. So they're at the same point at certain times, but not the same time. So that doesn't really do us any good. That's not guaranteed to be the closest to each other that they are. So let's see if we can just experiment with that in GeoGebra. I don't know if I recommend that you try to do this part because I'm going to do some weird stuff. But like maybe try. So what I'm going to do, we're talking about birds 3 and 4. So let me move the slider a little bit. So if you, I don't remember, it's like 2 videos ago that I started building this, I think. So what I'm going to do, I'm going to make a segment between birds 3 and 4 because the length of that segment is the distance between them. And then what I'm going to do is just kind of drag it around and see if I can find the minimum length of that segment. Like that sounds easy enough. So what I would do if I knew the names of these points, so this is where turning off the lid. So point E is there, and then is this F? Nope, E and H. E and H. All right, so 2 options. The easiest thing to do is actually just use the segment tool and like connect them, but I'm not going to do that. Well, I'll do that and then I'll delete it. So there to there you go. You got your segment. What I would have preferred to do, I'm not going to do it because it's already there. I would prefer to write segment and then just feed it the 2 points and it puts a segment between them. I'm going to change the color of this segment because it's like a random thing. So I just click, like don't click on the circle, but click on kind of the box with it. And then you can either change it here or up here. It's up to you. I'm going to change it here to, I'm going to use this orange color, I guess. That didn't work. Why are you still, uh-oh. Oh man, oh boy. Okay, hold on. What's going on? Why is any of this happening? Why are bad things happening? Okay, I'm going to click there and then change it here. Okay, it changed. So this segment is not a path that 2 birds are on. It is literally just the shortest distance between betweens. You don't hear that much between birds 3 and 4. So if I move, so now the problem is I would like to be able to see the length of it. Oh, you know what I'll do? Here we go. Let's do this. Let's right click. So 2-finger click. Settings. So click show label, but don't show the label, show the value. And we can see how long it is as it goes. And you can move it a little bit. You can't, actually you move it pretty far. I'll just drag it so I can see it. So right now it's 8.11. That's obviously not the smallest it's ever gonna be. All right, so I'm gonna, what are we counting by here? I'm gonna click on the 0 for my slider and change the step size to like 0.1. So now I'm just clicking there and I'm gonna use the right arrow. So 3.1, and you can see V is counting by 0.1s now. 2.4, 2.3, 2.08, 1.98, 1.82, 1.71, 1.67. Okay, and then it got bigger. I think 1.67. I think it's gonna be 1.66 something if we show enough decimal places. And it's gonna happen right around 7, somewhere between 7 and 7.1, I think is what's gonna happen. So that's what I'm thinking is gonna be the case. So what I'm gonna do now is I'm going to go to, well, I'm going to go back to the notes and like write down what I'm going to do. And then I'm going to go to the calculator and have the calculator do it. So we're using a lot of different things here, but you know, get used to it. The world's a little more complicated than it used to be. Got multiple devices going. All right, so what I'm going to do, so game plan and then like the work. My game plan, I'm going to do a vector of like bird 4 to bird 3, or bird 3 to bird 4. It doesn't matter. I'm going to find the norm of the vector. I'm going to graph that. And like, let's say distance is a function of time. I'll find the minimum. That's my game plan. Okay, so what does that mean in terms of what you write on your paper? Because like, it's one thing to do it, it's another like have the correct work that other people will recognize. So I'm gonna say that d of t equals, it's gonna be like a giant square root. So I'm gonna do the thing where I like start the radical and then like, go from there. All right, so quantity x4, the of t is really important. If you don't put it, then your calculator kind of like won't know what to do, really. So I'm writing the distance formula, even though on the calculator I'm probably not going to use it, which I know is like a weird thing. Let me go all the way across. Let that turn into a line like this. So does that look right? I think that looks right. Okay, so we're going to graph this. It's going to have a graph that's going to look kind of vaguely like a, it's going to look sort of like an absolute value, but like not exactly. And it's going to be distance and then time. I'm not going to fill it in right now, even though I'm pretty confident it's going to look like, and then this will be our minimum, and we'll know the minimum distance and the time at which it happens, but to the calculator. So what I'm actually going to do is I'm going to implement this plan where I'm going to make a vector, find the norm of the vector, define it as d of t, and find the minimum. But this is what I'm claiming that I'm doing on paper. You do a lot of this, where you're like, are you lying? I don't know, maybe. All right, so since I'm just following through, I have all these things defined, which is super convenient. So if I were to make a vector, I'm going to call it v of t, just a vector, v of t, colon equals, and then, so you can use, I kind of think that this is faster. Use the 1 row by 2 columns, 1 by 2 template. And then I'm going to do x4 of t, and then I'm going to type them y4 of t minus x3 of t, comma, y3 of t. So if you don't use a template, you have to put comma. When you press enter, it gets rid of the comma and you can never tell how it happened. And that's kind of a jerk move. So this is the vector. So if I type v of t, it's not going to show you like x4 minus x3, y4 minus y3. What it's going to show you is what happens if you actually subtract them. So like v of t is this. So that's actually like delta x comma delta y. So now I need the norm of that. So I'm going to say d of t colon equals menu 7, 7, enter, v of t. And press enter. If you want to see what it looks like, you can just type d of t, and you get this. If you watched a video a while back, you know that you can actually find the minimum of this by completing the square on this thing. Basically find the vertex, right? If you find the vertex of this, you'll minimize the thing inside the square root, which will minimize the square root, and you'll actually be able to do it by sort of hand, but I don't like your chances of finding the vertex of this by hand. So what we're going to do instead is graph. So doc4, graph page, got to be in the same problem where you lose all of your predefined stuff, but everything is just sitting in the vars key. So I actually want d. You have to use x because you're graphing a function of x. So d of x, press enter. You can see it does look sort of vaguely like an absolute value. So you don't have to do this, but so you can see like initially this is how far apart they are. When t is equal to 0, they're that far apart. A potential giant issue. Let me think this through here for a second. Birds 3 and 4 move for 12 and 14 minutes. If the minimum distance is at a time greater than 12, this kind of isn't really valid. And that's a more complicated problem that like maybe we'll deal with in another video. I don't want to deal with it right now. But basically you have to like stop your point and then use a different distance. You get a piecewise distance formula basically. We don't need to do that right now though. But it's like, it's kind of an interesting thing to think about. So, you know, if you're a thinker, consider thinking about it. All right, so I thought it would be between 7 and 7.1. I get 7.027, I guess, and then 1.666. So, ooh, that's ominous. So what I'm going to do is I'm going to actually sketch this kind of. I'll go back to the notes in a second. So this, and then I'm going to put a point there, and I'm going to label the point as 7.027, comma 1.666. Okay, so let's go back to the notes so we can see what I just did. And I mean, you probably also did it on your own. But let's compare. Let's pair and share. Pair and share? Yeah, pair and share. Pair up and share what we've done. So I got that the time is 7.027 and that the minimum distance they will ever achieve is 1.666 units. So let's write that down. So these are the equations. So the minimum distance between bird 3 and bird 4 is 1.666. We don't know the units on that. I don't know, bird wings or something. What would you measure bird? What would, not you, what would birds measure distance in? Like flaps or something? Like how many flaps it takes you to get from A to B? I think about that sometimes, especially like, because not everything has the same feet, you know, not all humans do, but we like agreed on a foot. I don't know, like do raccoons have like raccoon feet? In which case like every measurement is huge because they got tiny little feet. I don't know. And then this is at t equals 7.027 minutes. Okay, so not bad. I'm gonna stop the video here. I'll come back in the next one and deal with this last problem. I think it's the last problem. Yeah, it's got a lot of space, so who knows. Deal with the last problem in the next video. So save your GeoGebra file because we're gonna add to it potentially. Save your calculator stuff because we're gonna keep using it, and I will see you in the next one.